This term I did CCNA 3 and 4, and using the packet tracer program, we simulated a network for New Cloud Academy, and this would be the large scale possible network where we had the ability for 200 students to connect to the network and around about 50 staff members. So that falls under the first bullet of identifying the client's needs, basically how many people will be connecting to the network, how many servers there are and where the internet comes from, and how many different access ports the network users will need, and also how many departments you would need, and etc. IP addressing scheme is very important to create before starting the topology in packet tracer. This is the IP addressing scheme of the different routers and the switches, which are on a different network, the staff and student and guest access points, which are wireless, the printers that are also static IP addresses, and all the movable end devices are laptops and other phones and end user devices, which will be DHCP IP address assigned. They will not be documented. The documentation also should consist of the different host names of all the routers and static devices, switches and servers, and settings and iOS versions and naming of different ports on those devices, which are here under the interface column, and the IP address assigned to that interface with the subnet mask. The important consideration should be budget versus redundancy. In this packet tracer example, I've used a lot of redundancy where I've put ether channels between the switches. Then we also put a redundant link here as opposed to there, and the traffic can follow a link through this link here if that link were down. This is the CCNA router and engineering side and the main router. And then if this link were to go down, this link is very important to carry across to the engineering side. The physical topology is important to consider when looking at space and security, and distance constraints when looking at cable lengths. In this physical topology, we can put these 4 switches, which are part of the CCNA department, in one server room, or we could put it in different areas of the building, but that's all to do with the length of cable and space considerations, and also security, which you wouldn't want to put a switch at an accessible point where anyone can plug in their end device, although you would, in any case, disable unused ports on a switch. The different departments are separated by VLANs and different, so those would be virtual networks on the same physical network. So if a staff smartphone was connected to the staff access point here, it would be on the same network as the same staff laptop here, even though you're on opposite sides of the actual physical network. It will look like you're on the same network. Sub-interfaces are used on the downstream side of a router for VLAN trunks, which allow many different VLANs to communicate on that trunk. The routers versus switches, this would be beneficial to use a router to separate broadcast domains, where I've said sub-interfaces are used for VLAN trunking, whereas switches you would use for the access layer and to let end devices plug into that, where the switch can't intelligently route like a router IP packets to different networks. So we could have just used 2 routers in this example and used a first hop redundancy protocol where a virtual router would be between the 2, but that would only be really needed in a big business. The next point is the number of end users versus bandwidth. Looking at a guest access point here, or say the staff access point, similar in configuration, but say the staff are 200 people, or 100 people say, then this gigabit line here would have to support 100 different members. So that's 1,000 megabit divided by 100 users. Then that would only be, in theory, 10 megabits each. So it would be beneficial to have a gigabit connection there instead of a fast Ethernet, which would only give 1 megabit each to each user. Also, the trunks here are just to illustrate that we can do a ether channel between two switches, and also because I've only found that the switches have 2 gigabit interfaces, the one is used here and the other one's used here, so this is 2 fast Ethernet ports in a trunk, so that adds up to 200 megabits at giving redundancy if one cable is also removed, or just increased bandwidth. And you could have 4 cables here in the support channel, using up 4 interfaces, but then you would have less interfaces left for the end devices. Then the placement of the wireless access points should be in high elevated areas and line of sight to the user, and also away from metal objects and in the different 4 corners of the building. But bearing in mind, if you put it in the corner, you're going to broadcast just as far as outside the building as inside. So rather put it maybe center of the users in the central user area. And also use different Wi-Fi channels on the different access points to use the spectrum efficiently and have less interference and more throughput. The last point is VLANs, as I touched on before, was to reduce the broadcast domain and reduce costs to set up 3 different networks. In this case, we have a staff, a guest, and a student VLAN, which each VLAN has a printer, well, not for the guests, but then each department here has a server as well, which are on a separate VLAN. So different VLANs can separate network traffic and decrease broadcast storms, and basically implement security and only let the staff see other staff members and only students see other students. If you were to cross that boundary where you want to go to different networks, such as letting a user that is not in this network that the printer is in, so 10.10.0.10, if you were to print from a different network, you would need a separate access control list to permit that user to access a different network to print on a different network's printer. That's just a little bit about VLANs and access control lists. And these are some of the important things to consider when implementing a network for a new cloud academy that will scale to this size one day. And also, obviously, in the real world, consider these points when designing a network.